Hi, good morning. So probably some of you may have noticed the email I sent during the weekend. I got an order from something I cannot control, that we are unable to allow you to bring your electronic device, which is unfortunate fact. Because we need to cut down some trees and make things less convenient, but I don't have much choice on my side. I'm sorry for that. So that's why might be some of you would be used to looking at the T table and Z table and F table from Excel. So I want to tell you how can you create your own one. Well, of course, you can just download from the web and you'll be fine. Okay, but I just very quickly tell you how you can create those tables. Using Excel, you can just print that out, or you can just find something from the web. So what I look is maybe I just try to show you how I find it. I just Google it. Okay, just Google the Z table. There are many of them. For example, I just pick up one and I just recreate from the Excel. So say this one, right, is exactly the left area. Okay. So this is basically exactly the C dist true. Okay. So I can create one. Okay, using Excel. Okay. I think I said it last time, but I just do it again, showing you the how to create this, right? The Z, okay, and negative 3.4 and 0, okay, negative 3.3, okay, so and so forth. And this is okay. Now yes, that not that far. Okay, that's fine. Yes. Okay. So how to create it, right? Because basically just adding the column and the row will be the entry on that one. Okay. That is the C table. So basically just same as we do the multiplication table, will be just C dot normal dot dist. Okay, will be this number. Remember, you need to use the A for the value, right? And plus this one. Remember, you need to put 1 as the value, right? Sorry, S. Okay, and then true. Okay, so this should be same as the one you see here, right? It's 0.003. Okay, so you can put it here and then down, and then you can check your entry is same as there. Yeah, exactly. So you can this will be the data, right? So this will be C. This is C table. Okay, and some of you may ask, this table already actually tell you the other thing you call Z inward, right? Because this is area. Okay, so if you want to find the C inverse, it's go back, right? So if you want, say, what is the probability that 5%, right? So you go to 5%. Maybe I just make here one thing I can little bit tell you is here the decimal places is not really uniform, and look at the table, they all using 4 decimal places. So you can here change it to make sure that you have that common places. Make sure you have 5 the common places before. Then everything looks a little bit better. And then you want, say, 5%, and look at somewhere here. No, this is 0.5, so you have to go down a little bit. 5% is somewhere here. Okay. 1.7 something. Okay. So you probably need to look at it nicely, right? Probably you need to make it yellow, and also you want to freeze the plane, right? Freeze the top. Freeze the plane. Okay. If you go to the first column and row, freeze the plane, and then you go down. Why freeze? Not freeze the plane. Unfreeze. Why don't freeze in this way? Freeze the top row, right? So it will be 5% will be here, right? Okay. So that will be the way you do. Okay. This is the way how you create your Z table. Is there any question? So you will be using this one. You can print this out, or you can just go to the web, as I said, right? Find anyone you like, right? Maybe you can print out the Z table like this one, right? You can just pick up the Z table you like from the web and bring it to the test. Okay. I will not provide tables. Okay. You bring your own. Okay. Because some of you may bring the calculator that already have the table. So I don't see the need to bring the table. I will not provide tables. Okay. Or you can just pick up any table, or you have a textbook just the table already. Okay. So that's a Z table. And T table will be similar idea. Okay. But T table, you have something a little bit more. It's a T table. I tell myself through it. I just go to Google and look at T table. And probably you look at the T table, or just pick a random one. Okay. And you do notice sometimes they look like this. Okay. They would be instead of telling you in very detail, they tell you only different degree of freedom and different critical values. Okay. So just you would be using the critical value method in general for T, same as F. Okay. This is all they tell the critical value, right? So critical value means that what you'll be doing, actually this one will be the T inverse. Okay, this table. You can give you a T inverse. Okay. And this gives you the one tail or two tail. Okay. But I think the alpha is slightly different from us. Okay. In this tail, because it's a right tail, they're using different definition. Okay. Maybe so. Sometimes you can look at, be careful. This gives you the right tail. Okay. So this table, okay, gives you the right tail. Okay. And depend on what tail you want to use. Okay. But let's create a T tail table. T table. Okay. And so the usual T table. So usually 1 up to 60, 80, something like that, right? So let's do that. Let's do this style. DF is 1, 2, okay? And probably go to what they do is do to 30. And then 40, 60, 80, 100. Okay. 40, 60, 80, 100. Okay. Then let's see how they do it. They use the P value and T value, right? So it's right tail or one tail, two tail. Okay. Or the other one is also, look at this one, is somewhat similar. Okay. So maybe we just follow them. Okay. Okay. So maybe we just do one tail. Okay. Because this is what we have been used to do. That'd be our one tail. Okay. Maybe we don't need this one. Alpha can be, say, 10%, right? That's what we do. So follow them. 50, let's follow them. 50, 25, 50, 25. What else they have? 20, 10, 20, 15, 10, 1, 2, 1, 2, 2, 5. Okay, I think that should be sufficient. We don't need that much. Okay. How do we do that? That actually is easier, right? For the t-test, where to the t-tail, the critical value, right? Just the t inverse. Okay. So they will be just t dot inward. Okay. And this probability, remember you have to put a $sign in front of 1. Okay. And degraph this guy. Okay. Then you're done. Let's see. Oh, I forget the $sign for the A. Okay. So it should be look something like that. Look a little bit messy. So let me change it to the number to the 4. Okay. And just compare our data to the data available in the here. Seems the first column are all 0 and the second column are 1. Is that right? Yes, this is right. The next one is 1.736 and the third one is 1.79. Okay. So these are all the number, right? These are all the critical value, right? So basically what you're going to do is to compare this to your number, right? And here, probably the number here, probably you want a little bit more, right? Probably you think this is a little bit too less, you can add more, okay? 60 is too little, you can add a little bit. But you do notice why they jump from 60, 80, and 100 and say 1,000 like this. They don't have anything in between right? The reason is that you can see from 80 to 100 actually changes very little. Okay, so actually it does mean that the t-table do not need to be you are so concerned if you are say you want to check the degree of freedom as say 99 or say 70, then what happened, right? Usually what you're going to do is check the just linear interpolate, right? Suppose you want to have of course you for your exam you pretty want to you can create as many column as many rows as you want, but suppose you want to calculate this T90, right? And say alpha is I don't know what's alpha of this. The alpha here is 0.025, eh? So this guy, right? 0.025. Maybe 0.25, right? Then what we're going to do will be T80 and T100. Okay, you have 0.25 from the table, which is negative 0.667, and this is 0.67, right? So these are two numbers here, right? Also, it's this two number 77. Okay, 77660, right? So if you have 90, which is the middle, so you do this. Okay, so this is usually how you do the calculation if you have something in between. Okay, so this is how you use the t-table. Okay, of course, I don't provide the t-table for you. You can just create as many columns as you want. But in the case that you don't have enough, then you can just do the interpolate. Okay, so that is a standard thing you would do. Okay, so lastly, I want to tell you how to do the F table. Let's pick up the F table there. You should be able to create, let's Google the F table here. F table. Okay, look at it, depends on whether the right tail or left tail. Okay, here they give you the, this one gives you the right tail. Okay, and they also give you left tail, right tail thing. Okay, so let's pick up another table. This one doesn't seem to be very good, but let's create. Look at the other one. This one maybe. So you can see the F table is rather complicated. First, you have this one. I just randomly pick up a web page. Okay, the F table. First, you have to tell me the alpha, and because F table, you have three things, right? You have F, N1, N2, and alpha. Okay, so you have three-dimensional. Okay, so that's why it is not that easy to have one table. Okay, so here you can see already it's rather complicated. F, you have 1 up to 10 and 1 up to the number here for alpha, and alpha is 0.5 and so on and so forth. Okay, alpha is 0.25. Okay, and alpha is 0.1, so you little bit complicated. Okay, and so let's dig out this. Okay, so we do the F table. Okay, so we have to do it like different alpha. Okay, so basically you would need to have a three tables, right? Because the standard thing for the critical value, alpha is either 0.1, right? 0.05, right? And 0.001. right? Is 10%, right? Or the 95 or 99. Okay, so that would be the case, right? And but usually F test is in this way. So you can create your own F table. So let me calculate the first table is alpha equal 10 first. Okay. So what we're going to do is you need to if degree of freedom 1 and 2. Okay. So what are they usually using is 1 up to 10. Okay. No, 1 up to same as before, 1 up to 10, 60, 100, 12, and infinity. Okay. So it's something like this: 1 up to 60. Okay. And make it bigger. Okay. Like this. And 110t. And then infinity is very big, right? Very big. Okay. Very big. So very big is simple. Just make a big number. Will be sufficient. Okay. And same idea here. Since we are doing the same thing, then we just do a copy and do something we call transpose. Okay. You just copy and paste a transpose, and you will just rotate the row to the column. Okay. And to create this table is not that difficult, right? This is just F this. So we want the degree of critical value, right? So the T inverse. Now I want 10%, so it's 10%. Degree of freedom is first one is this guy. So you have to have a $sign 2, okay? Because of the is $sign A2 because $A is not going to change, okay? And degree of freedom for the first one will be $B$1, okay? Because 1 is not going to change, okay? So let me show you again the formula, okay? That is you look at the probability is 10%. So I'm creating the first table, okay? So then you just go to the end. I don't know how back you go into. Okay. So this will be the F table. Okay. The probability you will be. So this will be the F table. Okay. So so what we are doing is showing you how to do the T table, okay, with the Z table, okay, and telling you how to do the T table is T inverse, F is also inverse, okay. So do know that there's a slightly different between the T and F and Z, okay. T and Z is doing the inverse, okay, and C doing the norm as best, okay. Of course, if you like, you can also do the Z in the inverse form, okay. You can just look at the critical value also fine, okay. It's up to you how you want to do it, okay. So basically you are doing the F inverse, okay, and an inverse table for T inverse and the normal this. Of course, you can also, as I said, you can do the Z also do the inverse, okay. So of course you don't have, this is just trying to show you that how usually normal table is being done. You can just go to the web and download whatever the version you like, as long as you know how to use, that's fine. Okay, so today but now want to let you know if you have any question. Is there any question? before we can go to discuss, maybe we can discuss the last year paper. But before we do that, I want to ask if you have any question about the lecture, about everything we talk. Okay. If not, then let me very maybe spend 5 minutes to go back to here. Okay. Just very briefly, just one single page talk about what we cover in the whole semester, and then we go to the exam. Okay, go to the exam question. Okay. So let me very briefly review. So far, what we have learned. Okay, in probably the whole semester. Okay. So far, basically, you learn all the basic statistics tools that enable you to do everything. Probably you need to read any article that requires statistics. Okay, you have enough math knowledge to do it, and of course, there are always new things, but probably you just need to learn the new definition. Okay, but just very quickly. So the first topic we cover is descriptive statistics, right? So you should able to calculate what are the central tendency, the free measure, mean, median, mode, right? And what are dispersion, right? Is the range, interquartile range. Maybe I just go to exactly what they are on the next page, right? Maybe easier, right? And then what are the range, what interquartile range, right? How to calculate quantiles, what are the quantile function, right? What the variance, standard deviation, coefficient variation, right? And understand what is the population version, what is the sample version, right? I think by now understand what is the sample version, right? The sample counterpart is the estimator. It's an unbiased estimator. When you try to estimate the population version, you use those sample. Okay. Just a gentle reminder, right? Sigma, right? Square, right? It's like this, right? It's all the data minus should be the mu, right? This is the right? But indeed, when we calculate this, we use this guy, right? And the reason we have n-1 because we have x bar there, okay? And the main reason is because we never know mu, right? We always use this guy, okay? So that's why there's a little bit issue over there, and then this is the better estimate. This is used to is the estimator for this, okay? Same for the rest, okay? And we also learn skillness and ketosis, okay? And they are very useful measure, okay? And skillness is asking whether the data is asymmetric, right, on one side, and ketosis is whether you have the tail, longer tail or fatter tail, right? And we learn variance, covariance, and correlation coefficient, and we remember they're closely related to the regression we learned, right? And here I put all the bar chart and graph. Okay, I should put a star there, but just means that this something is you assume to know it and you should learn it. And I would expect you in your project to see that applied, right? You should show your data to the people, right? I didn't talk about this in the class in detail because you should supposed to learn it. Okay, I'm not. You should able to present your data in a meaningful way, right? And then table is important, right? Summary statistics, okay, these things are important, right? And the second one is about probability, right? And then we first start from definition from the classical way is about the relative frequency, right? So how many outcome that favorable to the event over the total number of outcomes if you do many experiments, right? This is the empirical definition or classical definition, as we said. And later, actually, we can do it without experiment, right? We can just define probability as satisfy some way to tell you what's the number for assigned for a certain event, right? Is we don't need to relate anything to the real world, okay? And that is how you later you learn, right? We learn how to consider normal distribution and so on and so forth, right? We actually do not look at the actual experiment, but rather we assume a certain style of probability distribution, okay? We learn union, intersect, complement, mutually exclusive, exhaustive, and partition, right? Partition is mutually exclusive, exhaustive, right? And we learn the probability axiom, right? We also learn the complement that imply the complement rule, total probability rule, addition rule, okay? And we also learn the odd ratio, right? And there's some conditional probability there. And the important part of this is how do you define independence and what is the most important thing, the Bayes rule? Because the Bayes rule is the way that how one should learn using probability, right? Because that is the basis of statistics, right? You have some data. From the data, you learn something new, and this something new is a knowledge, right? This is how you learn from probability. And this is counting, and probably at this point you know why we have to learn combination or permutation here. It is because this should justify why we learn binomial distribution. Okay, that is the reason why we learn things here. And the random variable here, the important part is trying to make sure that you learn, okay, what is the difference between discrete and continuous, right? And then they have different tools, right? And you do notice that the probability distribution function is indeed a bar chart, right? And for continuous, it's actually a histogram, okay? And you learn how to find expectation and variance, right? For the discrete, continuous, the integration, but we are not requiring that, right? And for the common diffusion, you have learned uniform, Bernoulli, binomial, Poisson, hypergeometric, right? And the most commonly used is binomial and Poisson, and hypergeometric, the three of them, right? And actually, Bernoulli we have been using all the time, right? When we talk about the binary data, yes or no data, okay? They are all Bernoulli distribution, we assume. Okay. And binomial, I guess this is so common, we have seen already, right? Because they are repeating Bernoulli's binomial, right? And when we talk about binary data, okay, this binomial. And we also know that when we do hypothesis testing on the binary data, right, we have the binomial, but actually we use normal to approximate that. That's why when you do binary data, it's always normal. The reason is because the underlying is Bernoulli, the mean is binomial, and binomial can be approximated by normal. Okay, so that is the reason. And for application, Poisson and hypergeometric there are many applications, right? Because Poisson is trying to measure certain kind of process, right? How many customers arriving, and hypergeometric is very important for quality control purpose. Okay, and continuous, okay, similar way. Of course, except the uniform, almost everything is used, right? Chi-square, we don't talk about that, but chi-square is behind all the student T and F. And you learn exponential is modeling the time. And normal, we are using all over the places. And student T and F is the way you do hypothesis testing, right? And also interval estimate, right? And that's we learn recent half of the semester is closely related to normal, student T and F. And do note that chi-square is behind the student T and F, okay? So that would be something you should know, of course, just know. And here comes with the second half of our course, okay? We talk about sampling, okay? And that's the reason why we learn probability, right? Because what kind of sample you draw is probabilistic. It's not known in advance. It depends on who you draw. And we learn what is the sample mean and sample variance, right? And the mean, the expectation of sample mean is indeed same as the population mean, but the variance is inversely proportional to the sample size, right? So if the population is sigma square, this will be sigma square over n, right? The bigger the sample size, the smaller the variance, okay? And that actually gives us the law of large number, right? Which means that when sigma go to very big, right? And basically you can see the sample mean is indeed the population mean, right? There's no difference when you do many, okay? And the next will be someone we have been using, but we are not probably aware to justify why we can assume sample mean is normal. Okay, a lot of time. Essentially limit theorem, okay, which essentially said is the sample mean is following normal distribution. Okay. And the next part is binary data. Okay. And binary data, you don't need central limit theorem or normal. Okay. Binary data, because CO1 is indeed a binomial distribution. Okay, by default. Okay. And we know how to consider their expectation and their variance. And in practice, although it's actually binomial, we use normal approximation. We always assume it's normal for binary data. It's because when np times, so n pi times n1 minus pi is bigger than 5, usually you can use normal. Okay, that is what we learn. And the next part is estimation. I guess that shouldn't be an issue for you, but what you learn is unbiased, right? And efficient estimator. And we learn basically the 3 main estimator for the basic thing: sample mean, sample variance, and sample proportion. And based on this, we know how to do interval estimator. You know the mean, you don't know the variance, you know the variance and proportion. Do note that when you talk about 1 and 2, okay, either you have to assume the underlying distribution normal, or sometimes you have to assume central limit theorem applies. Otherwise, the variance, okay, the whole thing is not following the T. Okay, so there is some assumption behind why you can do that. Okay, and same here, you assume the when you calculate mean, sample size, how many sample size you need. Here we need to assume normal. Okay, and proportion. And we have hypothesis testing. Okay, there are many testing procedure. Okay, I'm not going to go over one by one. Okay, and we have one sample test, Z and T and T. When you know the sample mean, sample variance, sorry, when the population variance is set, otherwise it's T, and proportion is always set. As I mentioned, it's a binomial, but we use approximation. Okay, so that's why it's always there. And we also learn 2 samples than many, right? You assume the equivariance, they do have equivariance, they have pair population, and also proportion, and also the F. Okay, so we at the beginning of class we mentioned how to construct the tables, so you should be able to construct it on your own, or you can print out the thing. Okay, and Anova, okay, by now you should know Anova is a generalization of the t-test, right? The t-test for this eco-variance. Okay, this is just looking at two populations. Okay, and Anova is asking the same question but more than two populations. It's more than one, it's many populations. And then you want to see under this assumption whether the mean are the same or not. Okay, that means that instead of doing t-tests all the time, compare many groups, you just do once and for all. Okay, and of course this is the first step you should conduct when you manage a group, right? And you just do once and you're done. And if you reject the null, then go ahead to see which group are different, right? You do group by group, but that is the first step to do, right? Just do aggregate tests. And well, because in the old days, the doing testing require a lot of calculation, right? So that's why we need to learn some more efficient way. And same as Anova, Anova is two-way, right? Two-way Anova and one Anova are slightly different. Okay, do note that you make different assumptions to the data generating process. Okay, so that means that if you do two-way Anova and one-way Anova, you may have different results. Okay, maybe two-way Anova, one-way Anova reject. Okay, two-way Anova say no. Okay, so you have to be very careful what kind of model in your mind you should do. Okay, you make some assumption on the underlying model, you should be very careful on what assumption you're making, right? Because remember, one-way Anova, you assume there's a classical model, there's assumption, right? And the two-way Anova also has other set assumption. Only if the assumptions are true, then you can use this kind of model. And you do notice that these assumptions are not mutually exclusive, right? Say maybe it's a little bit tricky, so that's why let me show you again the Anova assumption. I guess that would be important. So you do notice Anova, you need to assume this, right? For one-way Anova, you need to assume this is the model. Okay, this is the model. Okay, and two-way Anova, you are actually doing a different model. Okay, you're assuming this. Okay, so it is possible that you have two different conclusions from one-way Anova and two-way Anova. It's entirely normal. Okay, so the question is which one you to pick out. Okay, is your judgment. Okay, of course depend on data also. Okay, just to let you know, you have to be very careful when you deal with this. Okay? And finally, I think there's nothing new there. The regression. Okay, regression, I think you should be able to run your regression using Excel or on the Wednesday, on the Thursday, sorry, and the Wednesday we talk about R. Okay, and you should be able to interpret, right, the result, right, how to do the t-test, how to do the f-test, right, how to do prediction. Okay, all these are the basics. Okay, so is there any question? Okay, I think that would be good review on what we have done so far. Just want to remind you again the regression. Okay, what you put in Y and what you put in X, okay, should be coming from application, right? And what should be the what caused what, okay, or how they are correlated should be your model. Okay, you should think carefully, right? Because you're minimizing the vertical distance. Okay, you're regressing Y and X, and regressing X on Y is a very different thing. What you put in X-axis and what you put in Y-axis is a very different thing, right? So do note that that would have to be relied, of course, in the exam or you probably know, okay, you're given, but in the actual work, right, like your project, you have to be very careful. What should be the Y, what should be X, right? Because you are in your mind, you're thinking X causing Y. Of course, you can't prove it, but but that is the goal, right? You're thinking X is the variable. We're trying to explain Y. Okay, in some sense, we're talking about X is causing Y, but of course, whether it causes Y is outside the model. Okay, if you really want to use math to prove X cause Y, it requires an advanced technique that we can't cover. Usually, it's not covered in undergraduate. Okay, you have to go to master classes to understand various technique. How can you prove causality there? But at least what guides you is basically coming from theory, right, or common sense, right? Say example we said about the sales and advertising, right? So you know advertising should be the X, right, and sales should be Y, right? More advertising should lead to more sales if you are the company manager, right? It's very natural. That's what we expect, right? But if you are the manager of advertising company, you may think the other way around, right? Because you think if the sales goes up last year, okay, company with more money, more profit, more budget, okay, and they will spend more advertising expense, okay. If you're macroeconomist, right, or you're economist trying to predict next year advertising expense, then the x-axis will be the sales and y-axis will be advertising expense. Okay, so it's not entirely clear what is x or y offer, or it depends on really the purpose. Okay, and there's no hard and fast rule telling you what is y, what is x. Okay, it depends on the purpose. Okay, but in general, as I said, the idea x is you use x to explain y, right? So in the case where you are the CEO, you're trying to use the discover how your company sales are affected by marketing expense, right? So that's why y is the sales, right? And if you are the CEO of the advertising agency, right, and you want to use the last year's sales to predict this year budget for advertising, okay, so in that case, the sales will be the x variable, and the advertising will be the y variable. Okay, so you have to be very careful about that. Okay, so I guess we should take a break of I think 12 minutes, and then we will discuss the last year paper. Okay, in the meantime, if you have any question, you can ask me. Okay, during the break, you may want to check out the answer, because you can try to work it out a little bit before we start, because otherwise you just listen would not be very helpful. So I hope you can take the time during the break to take a look at the question a little bit, because I'm not going to read the question one by one. Okay, so try to take a look at the questions. Okay, so let's work it out. Okay, together. Okay. I also work. If there are no questions, I just work out on the board maybe. Okay, to show you how it can be done. Okay, I hope you have the question in your hand So I'm not going to show this because I think it's fine. I can show this. Okay. So the first question, okay. Let's see what is being done. So what the purpose of this question is trying to test your knowledge on probability. Okay. So the first part, what he said is 35% is finance, right? So basically like this. Probability of a random guy at finance is 0.35. Probability of accounting is 0.25. Okay. Probability of marketing is 16. The rest management. Okay. And in this school only have 4, right? So 1 minus the above 3 gives you the answer. Okay. I'm not going to do the calculation because I just tell you how this question being answered. Okay. You should try, you should at home you should try to work it out. Okay. That's why I didn't give you the solution. Right? Because you should try it out by yourself. Okay. And the question, the next part is among the major in finance, blah, 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 who live in dorm, right? So what is, I just showed you the first one. I think that would be fine. So what's this part is among in finance, okay? If the dorm is 40%, okay? And you can do for the rest of that, okay? So basically what the question they gave you is, they give you the basic probability and tell the conditional probability given their finance with a different dorm or not. Okay, so that is the question. Is that okay? So that is the question, the information there, but maybe I just write down in here in case you don't fully follow. Okay, maybe I just don't to be too lazy. I just write down here. Right, and dorm given you marketing, you 0.6, right? Given dorm of you of finance accounting. Okay, accounting, marketing is 0.3, and the final one is the management is 0.2. Okay, so this is the question. So you can see this question, I make it by myself, right? Because this is what happened in our school, right? Management means hotel management, I think. So the question now is A, what's the probability that randomly select student major in finance? Okay, it's major event who live in a dormitory. Okay, so basically the question is asking you, okay, to calculate that whether this question is asking this. Okay, question number 1, part A is asking probability that is finance and dorm, right? So this is, we will use the probability rule called the multiplication rule, right? So basically just very simple. You will just this guy and this guy, I multiply, right? So it's 0.4 times 0.3, 5. Right? Why I have this? Because this is the formula here. Probability A and B is probability A given B times for B. Right? So that's the rule. Right? That's called the multiplication rule. Right? So here is exactly apply the multiplication rule there. Second question is major in marketing or not, right? So that's it, simple. Marketing, right? Marketing and not in DOM. So make DOM C is DOM complement, that is, or not DOM, doesn't really matter, right? So that would be we'll be using, of course, this guy and this guy, right? And first, here I want to check, the complement rule, right? So which means that given your marketing, 30% are living in DOM, that means that 17% are not in DOM, right? So that means probability of DOM not in the DOM given your marketing is 0.7, right? So that's simple. At the end is 0.7 times 0.16, right? That's it. Okay, that's the answer. Of course, you can use calculator to figure out that answer, right? I'm not going to do that. Okay, that will be something you learn from the high school. Is that okay for the A and B? Okay, it doesn't take a lot of time, right? Just applying the rule. C is asking the following question. What is the probability that do not live in DOM? Right? Then there are two ways to approach this question. One, we can find out the DOM and find a complement. Okay? You can use this formula. Okay? You can directly find this one, or you can directly find this one and 1 minus. Okay? Either way you work. Okay? Doesn't really matter which way you want. Okay? And let me do the easier way because I want to do less subtraction. How to find the DOM. Okay? This one we rely on what we call the total probability rule. Okay? Because the probability DOM will be the following, right? Given your finance, you live in the DOM will be 0.4, right? So there's this number, right? And then given your debt is 0.25, is 0.6, right? So what you're going to do, this guy will be 0.4 times 0.35. This will be, as we have here, right? This guy, finance and DOM. And then will be 0.6 times 0.25. And you do the remaining 2, right? This is finance and DOM, right? And accounting and DOM, marketing and DOM, management and DOM. 4 add together is the probability of DOM, right? That is coming from what we call the total probability rule. Okay? So the first question is asking the multiplication rule, right? Asking the complement rule. And this is asking the total probability rule. Okay? And is that okay? Is that okay? Just ask, because don't worry, if you don't have time to finish everything, we just do it on Wednesday as well. Okay? Because I think we still have time for Wednesday. So don't worry about we can't finish on time. So, but any question, I hope you understand. I don't want to write out everything, because if you at this stage, if you still require me to write out everything, then you have trouble. Okay? Of course, you can ask me, but I'm not trying to write out everything in every single detail, because you're able to handle the rest. Okay? So now the question next is, what's the choice of major of student and whether students are independent? Okay? So testing independence is this question, right? Is asking the following: if A and B are independent, right? That's how you do, right? If they multiply is the same as the join, then you're done. Okay? So asking whether they're the same. Okay? So you have calculated DOM or DOM complement, doesn't really matter. You get one, you get this one, right? For the DOM. So how can you check? Or the other way around, the other text is probability A given B is same as probability A, right? Or probability B given A is same as probability A. Okay. So you either check 3 of them. Doesn't really matter which one you check. Okay. So you can check the following. Okay. You can multiply the DOM, right, with the finance, right? Is it equal to this one? Let me say it out again. I'm going to use this formula. Okay. I'm going to say whether first I have to check whether the probability DOM times probability finance is it equal to finance times DOM. Okay. If not, then we're done. If not, then we can check again. If yes, then we check whether DOM times accounting is equal to accounting and DOM, market and DOM, so on and so forth. Okay. That is the way how you test. Okay. Of course, if you are smart enough, actually this question is free for you. Why? If you want to check, this already tell you it's not independent. They're done. Actually, they're using this one. Right, this is B, sorry. Right, so just once, you don't need to do anything, just they're done. Right, because different major have different percentage living in DOM. So how can they be independent? They're done. Just free, completely free answer. You don't need to calculate if you are careful enough to think, right? If you use this one, you need to do some multiplication, but if you do this or this, then just work quick. Is that okay? Any question? Right? See, we spend less than 15 minutes to finish the one question. Question? Oh, it's very simple. Don't worry. So this one is given your major was already living in DOM. Okay. So the question is, let me go up a little bit. So the question is asking the following: probability that is major in accounting, what's in DOM? Okay. So basically you are swapping this guy because you have that here. Right? So this is the 2-part. So that's required to do the base rule. Right? So basically, if you know, remember base rule is the following: probability that is account, probability that is account given DOM times DOM. Okay. So that's why it's easy, because you calculate this one. This one is, oh no. major in accounting. Oh, I think this is easy. Major in accounting. Was probably live in dorm. Oh, you don't need to do anything. You're done. This is free. So just 0.6. You get free marks already. Okay. So that is the last two questions basically is free for you. If you're careful looking at it. Okay. So as I said, it's simple. Okay. But if you look at it the wrong way, you think it's Bayes rule, as I thought the beginner I read, then it's going to be take more time, of course. Okay. Any question for the first question? Of course, if I ask what is the norm is accounting, you need to do the Bayes rule, as I said. But even Bayes rule is simple because every number I've calculated already. Okay. Is there a question for the first question? If not, then we go to the next one. Maybe I can erase. Any question? Yeah, I erase. No question. Then I just do the second part. While I erase the board, you may try to figure out how to do the next question. The next question, I think I'm asking a normal. So this one should not be difficult again, because we're just applying the standard formula here. Okay. First, let's write down what it's asking. John is a property agent. Okay. He pays 6,000 per month plus commission. Okay. And his monthly commission is normal with mean 45,000 and SD 20,000, right? So that means his income is two parts. His income is Y, 6,000 plus X, right? And X is normal distribution with mean 45,000. And standard deviation of this, maybe just this, right? So this is the question that give you this information, okay? I just rewrite it in the notation form. You don't have to write it, but this is the way that the math looks like, okay? The question, the first one is rather simple, right? The question number A is asking the probability that Y is less than this number, right? And that is easy, right? Because Y is this plus X, right? So we just write 6,000 plus X is less than that, okay? Or if you don't want to write the math, right? You know his base salary is 6,000. Right? So you can just subtract 6,000. That is a normal, right? Because you just base salary is this one, right? Oh, sorry, it's commission. Oh, sorry, it's not. Sorry, it's asking this. So that's very already. Oh, sorry, the question A is very simple. The commission, right? So it's very simple. This is normal. So that means that this guy is a normal. Okay, and you know this is -1. Is it right? No. Right? Let me check. Yes, -0.1. Okay, so since we have done the Excel, so let's try to do it. Okay, look at the Z table. Okay, look for -1. Okay. Here, this is the area on the left, right? This is norm dot s dot this, right? So left hand side. Is it? Are we asking left hand side? Yes. That's the answer. No, this is 0.1. Sorry, 0.01 should be. Sorry, I should go to that. 0.01 should be here, right? This guy. -1. Yeah, this is number, right? So it's okay. Okay, so that would be the question number 1. How you answer it, right? Where's my question? Where's my question? Oh, here. Okay, so that's how you do the first one. Okay, I'm pretty sure we can finish it within 15 minutes, less than, right? The next question is, I'm not going to do it, but it's actually very simple. You know the first one or the second one? Okay, the second question is asking you to do x is between 30,000 to 50,000. Okay, so you apply the same concept here, right? So at the end, okay, I just do this one more time in case you don't know, right? Okay, so this, the number you got will be 52.5. Yeah, 0.25. And this is 0.75, if I call it correctly. Okay, so it's between 0.25 and 0.75, right? So let's look at the table, right? 0.75 and 0.25. Okay, 0.25 go to 0, I guess. Now 0.25 is here, right? That's how you find 0.25 is 5987. Negative 0.75 is here, right? 0.2878, right? And you do the subtraction, right? That's the answer. Is there any question? Yeah. Is there any question? Thank you. Next question. Okay, you can use your own T table, or that you can use your own Z table, but that's how you read it, right? 0.75. Oh no, I guess I read the wrong one. This is 6.5, right? 7.5 should be this guy. So this should be the you add up together, right? So it should be this number. Okay. So you see, you have to be very careful when you read the table. Otherwise, you make a mistake. Because this is how I construct the table. You have to look carefully what the table that tells you. Okay. This is how I created my table, and the next question will be 10% more than how much in a given month. Okay? So the question is the following. To asking commission, right? So it's easy. So the part C is asking the question is probability that the commission bigger than some number, small x, is 0.1, right? So just to understand this, you draw this guy, right? You are asking probability 1 is how much, right? So 0.1, right? Look at tail area is 0.1. Probably shouldn't be a big issue for you. You may have already remember 0.1 is looking at 1.2, 1.28, something like that, I guess, right? Right, 1.28. Okay, 1.28. It's a question. Okay. So that's very simple, right? That means probability that Z is bigger than 1.28 is 0.1. Right, because the other side is 0.9. Okay, now this guy is x minus, what's number there? 45. Is it right? And divided by 20,000. Okay, maybe just being lazy. This is Z. It's just 1.28. You solve for x, then this is the answer. Okay. So last question is oops. Oh, that's cool. So D, but I'm not that tall. That's a problem. Maybe I can clean this up. Maybe I can write here, yeah. No. Maybe I just erase. So the last part is a little bit tricky, I guess. There's a tricky part that I'm going to do. What is probably that is income is more than $1 million. Right? But the only tricky part is because several things. First is a year. Okay, so it's not just Y, it's actually talking about each month is independent, right? So this is not just 12Y, have to be very careful. So it just Y1 blah 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 blah. $1 million. Okay. This is the most tricky part. Second is, you know, there's a 6,000 per month, right? So we actually don't need to care about the base, right? So that's why I subtract 1 million minus 6 times, 12, 1 year, right? 12 times 6,000. This become his, this means his commission. Then this become X1, X12. Okay. So the tricky part comes in, then once you're done, right? Because the sum of this guy, right? The normal distribution with 12 times this, 12 times this, then that's it. That's it. Is that okay? Is there any question? Oh, sorry. Right? Then asking you this amount, which is the standard way to do it. Okay. The difficult part is just to know this. Okay. That is the most difficult part. Okay. The only difficult part is this is not 12 square. Okay. It's not 12 square. As you can see from the assignment already. Okay. It's not 12 times. The variance is not 12 square times it. It's just only 12 times. Okay. Because 1 month is normal. The other one is also normal, can be up and down. So the variance is not 12 square. It's just 12 times. Okay. Because this is different from this. If this, then it's still 12. This is right. But when we have only add up, it's just this guy. Okay. So that is the only tricky part for this part. Okay. You can see the first 3 part is simple. Last part is tricky. So you expect something similar, right? In the exam, right? There can be one part may not be the last part, can be tricky, but the rest should be simple. Okay. Is there any question? If no, then we go to the next question. So this shouldn't be difficult for this one, because you can see this is confidence interval estimate, right? And sample thing. So basically you just need to apply the formula. Okay, the first question is rather simple. Okay, the claim is following. So the government claimed the following: mu is 50, sigma, not sigma square, be careful, sigma is 12. Okay, so there's two items we know, and we know it's normal. Okay, so now you have sample of 80, so n equal to 80. Okay, and we have sample mean x bar is equal to 60. Okay, so what you want is 95% interval. That should be simple, right? This is x bar plus minus is normal, right? And you know the sigma, right? This is this guy, right? I don't think I need to go further to tell you how to do this, right? The only thing probably I want to tell you how to do this to find this guy, right? This is just plug in the number, right? Probably you need to figure this out. 95% confidence interval. Okay, remember 95% confidence is like this. 95%, so it's 0.25, 0.025, 0.025, right? So this is 0.975. Okay, so the left hand side 0.975. Look at the one that is closest 0.975, 1.96. Okay, so that is, you just plug in and then you're done. Okay, every number is here. 1.96, this, right? So less than 1 minute, you're done. That's write down everything. All right, so very straightforward. The second one is also very straightforward, right? Because that is a sample size, normal, you know the formula, right? N is equal to what? Remember? If you don't remember, okay, seems like you don't want to remember. That's fine because open book, right? So we go to, I think, estimation. Go to the sample size is this guy, right? Let's copy here. They're done, right? Y almost is done, right? Because the question is already, where am I? So the question is set 95%, right? So we already have this one, right? 1.96. This is done. This is done. And ME said within 2 minutes. That's it. So you get 10 points already, right? So basically it's free, almost free points, right? Just need to get the formula right, and that's it. Right? This ME is 2, in case you miss my statement. And that's it. Right? Not that hard. Is that okay? Any question? Any question? I don't think I need to calculate that, right? I think that should be not an issue. Is that a question? Because we don't need to hurry. We already covered everything already, so just make sure you understand. Now, part C is another question is you have the face-to-face learning. Okay, you can see I make this question last year, right? But don't worry, this is basically a same thing but proportion. So So if you can see the number, then you already meet this proportion, right? So that's not something hard. So how many samples you have? N is 100, okay? And how many of them prefer online, right? X is 55, okay? So what's P is 55 over 100. That is the sample proportion, right? Or 0.55. Okay. First part is asking you to do the interval estimate. If you remember the formula, just like this, right? P plus minus Z. Okay. You forget, let's go to the formula. It's here, right? Just above. So shouldn't be an issue, right? We know the alpha set over 2 is 1.96, all right? We know the P, we know the N, then done. Is that okay? Is that okay for this one? Any question? It's part C. Part D would be not that difficult again, right? Part D is now they figure out that pi is 0.6, okay? And the margin of error is 0.02, right? And we want 95% confidence. That's simple, right? This is just coming from this one, right? And is okay, that's it. You got this guy, got this guy, got this guy, got this guy, then you're done. Nothing deep. Okay, see, less than 10 minutes. Way less than 10 minutes, right? Okay. So I guess I left the last 3 questions of the next class. Okay. And next class we talk about how to do regression. Okay, just the first half we finish the R part and also we finish the remaining 3 questions. Okay. So try to do it before you come to class, then you know what we're discussing. Otherwise, you don't look at it, it's a little bit difficult to follow. But I guess at this point, you should not be too worried about it, right? It's very similar to your assignment, right? And you should expect similar thing would happen because that's nothing you can escape from statistics, right? It's almost always the same topic. Just you have to recognize what it's asking there. Okay? So I will see you on Wednesday in the lab. Okay? So say goodbye to the NA because we're not coming back. No more morning class. One more morning class for you guys.
The exam, is there any Excel formula?
Will be something like assignment 1 can be. We ask not really asking deep thing. You cannot answer what is the exam, but I can say we are not intended to ask you to write a spreadsheet. No. Just some basic. No, that's just a basic thing. Say what in the assignment 1, right? Say what is the input to calculate mean? What is the input to calculate this and that?
Not like
No, not writing a complicated thing.
Alright.
So some very basic thing if I ask.
Okay.
Do you upload the answer for?
No, I'm not uploading the answer for this one.
Okay.
Answer is not upload. Yeah, because past exam usually don't upload the answer.
Okay.
But if the question can ask me because I already discussed it already. Right?
Yeah, because like if there's upload, I just want to like ensure that all my calculations are correct.
I see.
But
But
it's
usually I don't upload final file. I mean the assignment is already similar, right? So I think it's okay.
Thank you.
所以呢個嘅 marginal error 係
0.02咧，
但係正負0.2嘅。
就係0.02啦。marginal error 就係左右噶嘛，所以0.02得噶啦。
哦。
好似assignment 1咁咯，個基本嗰啲咯。assignment 咁問你個 formula 係乜啊咁嗰啲咯，譬如問你 C test 嘅 formula 係咩啊咁樣嗰啲，好 basic 嗰啲嘢，好 basic 嘅。